Okay, let's start. Good morning, everyone. I hope you enjoy this review session. Okay. The grade submission day is May 15. Okay, so 15 it is at noon. So 15 more days and you are done. Or maybe you stay with me next year or something. Okay. I'm here to help you to pass or get A or maybe A plus. Okay. The exam date. Okay, if you come, I think it's 11 at 4:30 p.m. Okay, we will do the exam in this room and 204. For those who request to X time, 1.5 X time, if it is allowed by the university, they will be in during lab. Okay. Once you finish the test, you have to submit everything. Okay? Submit everything so that you don't have any document to discuss outside, because some people will sit outside. Okay? The room may not be big enough to spread everyone. Alright, the content of the exam is comprehensive. The lecture 1, we talk about safety, engineering ethics. So you should, I think it will be in true or false. I cannot have calculation question on that. Okay. So the thing about ethics is you've got to know that even if we are not PE, but we are abide by this rule. Okay. And fundamental canon, engineer is in the fulfillment of their professional duty shall promote the safety, health, and welfare of the public, and blah 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 blah. Okay, say something good. Okay, I think it's very. I don't try to play any trick. Okay, if it's something that ethical, say it is ethical. If it doesn't look like ethical, it's not ethical. Just that. Okay, it's no trick on this. This is the purpose of the very first lecture. All right. Try to review that. Second one, I go to 2.5. This is a presentation made by GNT. We talk about the average molecular weight. You're going to be able to do this, okay? If you cannot, I would like you to stay with me, okay? So, weighted average molecular weight is a weighted average based on mole percent or volume percent, not mass percent. We talk about this, right? How to do each column. You got it? Yes? You know how to do it. That's number 3, number 4, number 5, number 6. So, mole percent is the same as the volume percent. Alright? Mole percent is the same as volume percent. If we have the weight, if the weight is given, I think you have the exam solution, right? Did you review that exam solution? Oh, please, exam solution, not the midterm exam. How do we go from weight percent to volume percent? It's a weight divided by molecular weight, right? Because look at column 6. Column 6 is what do you do? Actual weight of the component is mole percent multiplied by molecular weight. But if we want to go from weight percent to volume percent, it should be that divided by that, okay? So we have weight divided by molecular weight. And then that will be kind of volume fraction. Good?
So you want us to give you mole or volume percent, but you have the formula there for weight percent.
If the composition is given in weight percent, I can say.
The formula that's up there is not the one that you want us to know for the test.
You should know that. It's the same thing.
Do you understand what I'm saying now?
It's not directly the one that you use.
Right.
It's not direct. Okay, it's indirect. You just have to move that over there in the bottom, just that. So you got to be able to convert from weight percent to volume percent, convert from volume percent to weight percent. And the molecular weight is the weighted average based on volume percent. Okay? Can you do it? That's 9 points. If it appears in the exam, it won't, if it appears in the exam, it won't be in true or false. Okay. This is like mole percent equal to number of mole of component I equal to weight percent divided by molecular weight. So I have that over that, I get that mole percent at column 5. Okay, and I get total of that. Then 2.69767 divided by that multiplied by 100 equal to that. Right, you do it for all of them. So try to do this. Please. Oh, okay, by the way, that I promise you that I won't give it to you, right? At best, I will tell you nitrogen. Nitrogen is N2, not N, okay? Nitrogen is N2, not N. And you will know oxygen. Oxygen is O2. It is your task to write those in, okay? And the component is like C1 to C5, and you should know, okay? What is C1? CH4, right? C2, if you don't remember, it's C. So each carbon has 3 hydrogen. So this must be C2H6. Okay. So it's C. The formula for N alkyne is CnH2n plus 2. Okay. So this would be ethane, okay, methane, ethane, propane, butane, okay, heptane. Do you know how to those names work, right?
No. What is it if it's C3? You got 3 carbons?
C3, we got C3H, 3 multiplied by 2 equal to 6 plus 2 become 8. So we have C3H8. Okay. Each carbon has molecular weight of 12, right? Is it 12? Okay. Each hydrogen is 1. Okay. You add them together, that is molecular weight. So in the test, very likely you will have just a name. Like for example, you have ethane. Okay, ethane. You have the name propane, and you have to tell, hey, propane is C3, C3 has to be C3H8, and then molecular weight will be 12 multiplied by 3 plus 8, whatever that is. Okay, you can do this, can you? So the trap may be...
Will you give us the molecular weight?
No, I don't give you the molecular weight.
What, will you give us the molecular weight of carbon?
No, I don't give you any of that. I promise, I want. You write it down, okay?
We're supposed to know what argon is?
Oh, okay, write it down. What's the big
Can we
deal?
bring up your exam?
No. Everything that you put it in.
I mean, can we print it?
No. Printing. Everything has to be your handwriting. Everything has to be your handwriting. Okay. All those 8 pages has to be your handwriting. Come on. There are limited time. Okay. The thing that is fair for the test. No question yet. The thing that's fair for the test is the word. Methane, okay, ethane, propane, butane, pentane. Those are fair for the quiz. In addition to that, the word nitrogen, the word carbon dioxide, the word oxygen, and argon and neon. That's a fact. I don't think it's in the test, but if it is in, I'm not gonna tell you that it's 40 and 20. That's it. The rest of that, okay, helium is 2. Most of the time, those things is not in it's unlikely that those things is going to be in. But okay, right now you know that, okay, argon is 40, neon is 20. I don't confirm you, but I don't think that is in the exam. But okay, write it down for you to feel happier. But the word like nitrogen, if you put nitrogen as N, not N2, then it would be 14 instead of 28, right? So you're going to know that question.
Why are we spending time like caring about this when we can just look it up?
You don't have any idea because half of the class get it wrong. Half of the class, maybe you get it right. But another 50% of the population get it wrong. What do you want me to do? Fail them, give them F or what?
There you are.
I want them to pass. So we go through this.
They didn't get it the first time, they just.
All right. This 2.5, number 2. Oh, where's number 2? This number 1. 2, number 2. So this is about facility. For very popular question is, when do we show if we have single pass line heater? Before we show before the line heater, or we show after? We heat it, then we show. Okay, we don't show before heating. Okay, whatever I say here. Now this is when it doesn't form hydrate. If we have line heater, we heating it up before we choke it. Or we can heat it for split coil. We can heat it, choke it, and heat it again. That's for split coil. Single pass, we just heat it, and then we choke it. All right? That is single pass coil. You remember that? And last year, 2 years ago, I think we asked about indirect heating and direct heating. Line heater, is it direct heating or indirect heating? Line heater. You're gonna have to take this 11 days wrong minus 1. Line heater has water inside. You remember? Line heater has a water bath thing. That's it. It is not in this line. Okay. Line heater has water bath. So it's indirect. Heater treater doesn't have water bath. So that is direct. Okay? That is very popular question. So this is true or false. Okay, calculation. The calculation part, you got to be able to know how to use this chart. What you need to know is this side doesn't have hydrate and that side has hydrate. Just that, right? If you don't know it, okay, your score become mine. This tells hydrate formation temperature. Okay, hydrate formation temperature. This is pressure in PSIA. Every time we do it, do PSIA. Okay, PSIA. Hydrate inhibitor, Joule-Thomson. What is Joule-Thomson? What is Euler diagram? Euler diagram is a chart of enthalpy and entropy. That's Euler diagram, right? Okay. What is Joule-Thomson? Joule-Thomson cooling. What is it? Joule-Thomson is the change in the temperature due to the pressure drop across the stroke. That is one way to express the Joule-Thomson. Joule-Thomson can be expressed as the decrease in the temperature when we have significant pressure drop. Typically, flow across the stroke is a constant. Constant what? S or H? H. Okay. Enthalpy. Okay. Enthalpy. This is a phase diagram. Okay. I have to zoom in to do this, so it's a little bit difficult to put in an exam. This one is easy. The purpose of this thing, look at the correction factor. Okay. Look at the correction factor. If we have BBL per mmCF, when we have more liquid produced, we add more temperature over there, you see. So this means if we have liquid co-produced with gas, a lot of liquid co-produced with gas, there's no delta T, there's no temperature drop, okay? Got it, right? Because when we co-produce just 50 barrel, temperature, delta T has to be decreased by 15. So you need to know how to use those factors. Look at this one. If no oil produced, we do this, and that's the case where we have oil produced. If oil production is 20, no correction. See, no correction. If no oil produced, okay, we have minus 10. Which is that. So we have additional temperature drop if we don't have any oil produced. So this graph tells us that if we have more oil produced, we have less temperature drop. Okay? That's you need to know. Okay. This diagram, what is the name of this diagram? Euler diagram. Okay. Euler diagram is a plot between enthalpy and entropy. Notice that they are specific. Enthalpy is per unit mole or per unit mass. Okay. Your job is know the unit, know this unit. At least just on that day, it's okay. Maybe you don't know it now, but the unit of specific enthalpy, the unit of specific entropy, you got to know it. Okay, what is the unit of those things? BTU per pound mole. This is BTU per pound mole per degree. What is that degree? S is BTU on the top and pound mole, LB mole, and degree R is on the bottom, right? So that's on the bottom. You got to know the equivalent SI for this field unit. Okay. In SI, BTU convert to what? Joule, right? BTU become J. Pound mole become just mole or kilogram mole. Röntgen become Kelvin. Okay, right? You need to know how to read this chart. If you don't know, it's a little bit too late. Okay, this is a constant pressure, this constant temperature line, and how we do this hydrate curve thing. There are two charts, this chart and another one is this one. Okay, do we know how to use this? You know that, right? Okay, that we have to heat above the dashed line is the hydrate formation temperature. Okay, in the calculation section, if I ask what is line heat firebox rating we need? Okay, this give me BTU per pound mole, right? This give me BTU per pound mole, and if I know how many pound mole per day, then I can calculate firebox rating. Firebox rating. This is an example, and roughly we have this number. Okay, 1 pound mole is about that much standard cubic foot. Okay, if you want to use that number, unit conversion. Please have the unit conversion from barrel to cubic meter, barrel to liter, all those things you need to write it down. Unit of R, what is the value of R? You need to write it down, okay? R has several kind of value. One popular that we normally use is 10.73, it's feet, PSI, Röntgen, and pound mole, okay? Alright. Line heater, and that's the most calculation we have. Log mean temperature, the formula for calculate log mean temperature is just writing the formula, right? Oh, okay, this one, 109.9 heat required BTU per hour. Okay, this is about the amount of heat BTU per hour. Use substitute the gas flow rate over there, right? And have the difference in the specific enthalpy, and then we get Q in that unit BTU per hour. Good. This is for firebox rating. Okay. The other H come from those charts. Did I promise you that I don't ask about any of that? 109.9. You remember there's a quiz similar to this, like we talk about density or something, and we have the value of C and specify the value of C. The easy thing that we did in the quiz twice, got to do that correctly too. Okay. Heat duty, add everything, fire tube size. It's just a formula. Did we test it last time? I don't think we had it last time. Pressure drop inside the coil, so this is a formula. I think you already have this formula in your information sheet when you take the first exam. And this is how to use a chart. You know how to do that, right? You did the example. Oh, okay, erosional velocity. So erosional velocity has to be compared with the inside velocity, actual velocity. If the actual velocity is more than erosional velocity, then we have erosion problem, right? Okay, so this is the way to calculate erosional velocity. C value come from a certain table, okay? And that table should be given, I think, 300, 400 or something. If we have it, that C value has to be given, otherwise you cannot select the right choice or select the same choice. Okay, this explain again how do we get each column, okay? Erosional velocity has this formula, C over square root of rho, and rho is pound mass per cubic foot. Okay, that's V sub P. I go across this equation, rho equal to something, something, something. Does that matter for you? This is to calculate the density of gas, right? Based on specific gravity, pressure, temperature, and compressibility factor. So this means this formula is like very good. You should have it. It's to convert from specific gravity to density. Okay, when we know temperature and pressure. Okay, the rest is, what is this thing? Get the Z value, right? You know how to read it. It's compressibility factor, PSIA, and this is the temperature in Fahrenheit. Just read it. Very easy, right? How to read the chart. Actual velocity. Okay, this one is very popular in previous exam. 60 multiplied by Q, G, T, Z over D square and P. So this account for, this automatically convert from actual, standard flow rate to the in situ flow rate, correct? It's convert from standard flow rate. Standard flow rate is at the standard pressure and temperature, and then it converted to in situ flow rate. So even if the standard pressure may not be 14.73, maybe just 14.7 or 14.65, this value is not going to change much, okay? It changes a little bit. So this gives me the velocity in the unit of feet per second. This is for gas, okay? And that P is the pressure PSIA, okay? That D is in inch, T is Röntgen. What do I do with this equation for multi-phase flow? Can I use that for multi-phase flow? Of course, I have a chart that have VSL, VSG, okay? If we use this equation, that is equivalent to assume that only gas flow through a pipe, right? This equation is equivalent to assume that only gas flow through a pipe. Then it gives me superficial gas velocity directly. So if I tell you, hey, I have 1 million standard cubic foot per day flow through a pipe, the temperature of gas is something, something, pressure is something, something, compressibility factor is 1, the inner diameter of the pipe is 3 inch. In addition to that gas, I have oil flow in the pipe, oil flow at like 50 gallons per minute or something. You use this formula and you convert from feet per second to meter per second, then we can read the flow pattern map. You remember? Flow pattern map is the plot between VSG and VSL. We will review more about it. But can this is the equation to get the actual velocity inside the pipe. If it is single phase flow. If it is two phase flow, it gives you the velocity as if gas is only the only phase, which is the superficial velocity. This is how it's derived. LTS unit, know the name, of course. Low temperature exchange unit. Diagram is, you need to know that, okay, I think I have some correction, but the choke is inside this or something. This choke, we choke inside and it's like have temperature drop. Okay, hydrate inhibitor. This is, you got to know this three. There are three kind of inhibitor: thermodynamic inhibitor, which is methanol, kinetic inhibitor, anti-agglomerate. We talk a little bit on the fluorescent thing, and that's a little bit is enough to put in the exam, okay? So methanol will be thermodynamic inhibitor, okay? And what is the equation that comes with this? Hammer-Schmidt equation, right? Hammer-Schmidt equation is for calculation of thermodynamic inhibitor. Okay. Kinetic and anti-covalent, we just buy it. LDHI, low dose inhibitor, it's been put a little bit in and it just works. We kind of skip that, right? Hydrate base practice. Oh, we have this thing. For you, K value will be given if we have this. Okay, this is K value for Hammer-Schmidt equation. Your job is know how to use this equation. Okay. The other thing is that depression of hydrate formation temperature. MW is the molecular weight of inhibitor. Molecular weight of inhibitor, methanol is 32. Will give you that. I think I give you that. Okay. Methanol is 32. K value, I will give you that. So this has to work with what? Hydrate formation chart, right? That is a diagram and tell, okay, if my hydrate temperature, formation temperature is 60, my flow rate is, my actual temperature is above that, then I have to add more inhibitor until my hydrate temperature go down or something. You know how to do that? Yes? Yes? Yes. No. My flowing temperature, assume that my flowing temperature is, current temperature is 60. Okay? Hydrate formation temperature is 63. T hydrate. Where's the T hydrate come from? Reading the chart. What chart? This chart. This chart tell me hydrate. If it is in the exam, it will be given. Okay. So this chart tell me hydrate formation temperature. And let's say we use that chart and we found that hydrate formation temperature is 63. And our temperature right now is 60. What do we do? And the instruction will say, okay,
We need to drop the hydrate formation.
the instruction should say that, hey, to be safe, the company policy is we have to flow at about 2 Fahrenheit above hydrate formation temperature. Or maybe I may say we have to flow at about 5 Fahrenheit or 3 some number Fahrenheit above hydrate formation temperature. So let's say my company say I have to flow at least, not at least, about 5 Fahrenheit above hydrate formation temperature. This means I have to add inhibitor until the hydrate formation temperature become 55, right? If hydrate formation temperature become 55, this means it's 5 degrees below the current flowing temperature. So this makes the delta T to be 8, right? So that delta T is 8. That's my equation. We put 8 over there. We know everything else. We can calculate W. W is the weight percent of inhibitor in final water. Right? I noticed that there's some quite a big approximation. So on the way that the example from Arnold Stewart is done, I won't penalize you. So W is the weight percent of inhibitor in water, not in water vapor. It's in water liquid. It's not in gas. It's not in liquid hydrocarbon. Okay, it's in water liquid. So when we say weight percent, we cannot really do like 0.11 multiplied by 220, right? So this is like kind of big approximation because actually 0.11 will equal to this 220 is amount of water, right? This is equal to volume of or mass of inhibitor, methanol, over mass of methanol, MEOH, plus 220. The actual thing should be that, but in Arnold Stewart they assume and neglect that thing. So this I will tell you how exactly to do it in the exam. Don't worry about it. Okay? I'll tell you how exactly to do it. If you follow this instruction, I cannot penalize you because I don't have to do any correction in the last minute. You will be changed in the next one. All right, the rest of it is a little bit like more on how much methanol go into. Did we have this thing in the midterm exam? No, I don't think so. I don't think we have calculated midterm exam. Then it should be where? Final exam. Then it should be final exam. It should be in somewhere, okay? It should be somewhere.
We did it on the homework.
But it's already in homework.
Yeah, we didn't do it.
Okay, maybe it's in the exam again. So this is how to calculate the total amount to do it. Okay. We have 10 questions for this calculation. We have 30 questions for true or false. I do true or false within what? You don't know this information? This is posted on the blackboard, isn't it? This is the first 2 pages of the exam. Like, we have 30 questions for true or false and 10 questions for like calculation question. You know that, right? You don't know that? Is it not on the, not on, is it over there? Oh, not this topic. Totally. So, true or false, I did it in 5 minutes. Okay, you may do it in 30 minutes. So, you will have 2 hours left. 2 hours is 120 minutes. Okay, so each question, it has to be easy enough so that you can do it within 12 minutes. Okay, you can do it in 12 minutes. And look at the quiz. You remember the quiz that has C constant? I give you 10 minutes and you finish in 5 minutes or something, so you'll be just fine. Okay. The calculation question, it won't be too complicated. It should be able to solve within 12 minutes. Okay. This thing, if you do the whole thing, it will be longer than 12 minutes. So if I put this in, I have to help you a little bit, give you some number already. Okay. This is number 2. Number 3, separator. Separator, you have to know the size. Okay. The shape, whether it's a vertical or horizontal. The benefits, disadvantages, you know. You have to know main internal component, which is inlet diverter, oil bucket, water bucket, and what else? The mist extractor, and you need to know the location of what's that? Pressure relief valve. Okay, pressure relief valve has to sense the build up of the pressure if the mist extractor gets plugged. You should not put the safety relief valve afterward. Okay, and that even if that is not in the exam, I think it should help you. There's a pressure relief valve. This is the mist extractor. So if you have pressure relief valve is not there. It should be somewhere over here. Okay, you will put it over there, not that thing. Liquid collection section, mist extractor, and okay, you just know that the mesh type is the cheapest one, right? More expensive maybe chevron type, and the most expensive will be the filtration thing. What more can I answer this question? Okay, this is half filter tube. Oh, about this, what is this? Slug catcher, another slug catcher. We have this in the midterm exam, I remember. This is the diverter, centrifugal type inlet diverter. So if I erase this, you know what it is, right? Defoaming, wave breaker, liquid outlet, vortex breaker. Just need to know the name, okay? Steering well, mist extractor design. Okay. It looks like that. The price and the shape. Sauter-Brown coefficient will be given. Okay. This is Sauter-Brown equation. What is that for? Maximum Weber velocity. We should not exceed that. If we exceed that, this means the separator should be fatter. okay, or larger, have higher diameter. I may have a chart, I draw it already, and I say, okay, according to the separator chart, we should use the size of blah 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 blah, like 36 inches by 20 feet or something. Check if the gas velocity is consistent to the allowed maximum Weber velocity from the Soderberg equation or not. Should be able to do that. True or false, maybe. Maximum velocity of allowable, same unit as K, rho L, liquid density, Weber density. How do you get what Weber density? That 2.3 thing, you remember? 2.3 multiplied by something something. That I have equation rho equal to 2.3 multiplied by something 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 big gamma. You remember that? I showed you previous slide. It is from ideal gas law. From ideal gas law, we can convert from molecular weight, right, to density. So you should be able to use ideal gas law or use that formula to calculate density. There's about mixed extractor, settling volume. We have terminal velocity equation. Do you have that equation already? And if we have you substitute the value, you don't mess up when you do the calculator thing, right? Okay, that should be it. No iteration in the exam. Okay, cannot be done in 12 minutes. Okay. The field unit thing, or you know that number, if you don't know how to divide it, you write it down, okay? So this is like C value thing. But this kind of value to divide it is take quite a little bit longer than 12 minutes. Okay. But if you already have it, I put the yellow box on it, right? So you should write it down. So this is calculate the Reynolds number based on viscosity in a comfortable unit. Okay. And of course you have to be able to convert from pound per cubic foot to cubic meter, or kilogram per cubic meter. Do you have that? You should have that. Okay. Design droplet. Okay. Mix extractor, remove 10 micron and above. There's a half full separator, gas capacity equation, liquid capacity equation. Okay. So even if the exam is easy, just plug and chop, just like substitute the value and ask you how much. I may say, okay, use vertical separator equation to calculate the diameter based on the gas capacity QG. I give you the unit, okay, equal to this, Z equal to this, temperature equal to this. I don't tell you the density, but I tell you the temperature and pressure, and I tell you the molecular weight of the gas, and I tell you CD equal to something, diameter of the droplet is expected to be some value, or d sub m, what is the value of d sub m, defined over here in micron. Okay, the droplet is 10 micron. Based on the horizontal vertical separator gas capacity equation, what is the preferred diameter? We just put the number in, take the square root, and get the diameter. Seems to be easy, right? It's not easy because there are several equations, and if you don't write it in, you can get a point. That's my point, right? So basically you should already have it in your information sheet. Okay, your handwriting only. This table. Did you write down about this equation or anything? Or I tell you I will have it for you. I didn't say anything about it, did I?